Hello friends, welcome to engineering tutorial. So in the previous few videos related to semiconductor physics, we discussed about various basic concepts related to the crystal structure, the types of crystal structure, and the various crystal lattice cells, unit cells that are present. So in this video we are going to discuss another aspect of semiconductor physics, okay, the way in which it is studied, a tool. You can think of it as a tool to study the physics of semiconductor devices, and that is quantum mechanics, okay, quantum mechanics, or we can call it the quantum theory of solids. Basically, here when we say solids, it means semiconductors. Now, so let us first see what is quantum mechanics is all about. So, quantum mechanics, it is a branch of physics that deals with the subatomic particles, okay, the motion, the interaction, everything related to subatomic particles, that is the electrons, protons, neutrons, and all those things. So basically it tries to explain the properties in terms of the atoms, molecules, and their constituents, okay. So the smaller viewpoint, okay, the classical mechanics is all about larger size bodies, okay. Quantum mechanics is all about the smaller, the smallest constituent structural units, the electrons, protons, neutrons, atoms, okay. So that is what is all about. Now why do we need the quantum theory in the study of the semiconductor devices? Now we know that the current flow in semiconductors is due to the movement of electrons and holes, okay. Now we have already discussed about electrons and holes and all of that in the in a video related to the semiconductor physics basics. You can check out that. There I have discussed about electrons and holes. So the current flow in semiconductors is because of the movement of electrons and holes. So these are the two main the factors related to semiconductors, okay. Now in order to understand their behavior, their interaction, their movement, their properties, their features, we need quantum theory, okay, because quantum theory deals with subatomic particles, smaller constituents, smaller units. So that's why we will need the quantum mechanics, the concepts of quantum mechanics, to study the behavior, properties, and characteristic features of the semiconductor materials. Now which basic concepts of quantum mechanics are going to be used? Basically we will be studying about three main things. First, the energy quanta principle, the wave particle duality principle, and the uncertainty principle. These are there are other things, but these are the three main things, three main components of quantum mechanics which are required in the semiconductor physics, the study of semiconductor physics. So let us discuss them in quick one by one. First is the energy quanta principle. So this principle is a contribution of Max Planck. So in 1900, Planck postulated that the thermal radiation which is emitted from a heated surface, it happens in discrete packets, okay, each having a certain amount of energy which is quantized, okay, and that is called as quanta. This is also similar to the concept of light photons, that's why it is also called as photons sometimes. So the energy, the thermal radiation which is emitted from a heated surface, it appears in the form of discrete packets, distinct packets, each having a fixed value which is called as quanta, and the value of that energy quanta is given by this equation: E is equal to h nu, where h is Planck's constant, nu is frequency of the radiation which is emitted. Here we are just discussing them quickly, we are not going into detail. So this is the energy of the packet, the discrete packets, a single packet which is emitted, which is directly proportional to the frequency of the radiation, and h is Planck's constant. Now the next one is the wave particle duality principle. So this is a contribution of Louis de Broglie. So in 1924 de Broglie postulated the existence of matter waves. So basically what it means is that waves, they exhibit particle like behavior, then it also means that particles should exhibit wave like properties. So this is what wave particle duality is all about. Waves exhibit particle like behavior, particles exhibit wave like properties. So these two things are interrelated by these two equations. Okay, so here again the quanta or the photon comes into play, photon particle. So the momentum p of a photon particle is given by this equation, h by lambda. H is Planck's constant again, and lambda is the wavelength of the light photon. So by this and this equation, by using the same principle, we can determine the wavelength of this photon, this particle. So the wavelength of the particle can also be determined in terms of the same Planck constant and momentum by this equation. So the wavelength of the same particle can be given by h by p, Planck's constant divided by the momentum. So this is what the de Broglie principle or the wave particle duality principle is all about. Momentum is Planck's constant divided by wavelength, so wavelength will be Planck's constant divided by momentum. Okay, so this is a wave exhibiting particle like behavior, and here a particle exhibiting wave like behavior. So this is what the wave particle duality principle is all about. So remember these two equations, means the same equation, just we took one to the LHS, brought one to the RHS, the same equation. So these are the important the equations related to that. Now the uncertainty principle. So the uncertainty principle is a contribution of Werner Heisenberg. Again, it is applicable to subatomic particles, and basically it revolves around the concept that it is almost impossible to accurately track or describe the properties or behavior of the subatomic particles, which includes atoms, electrons, whatever, all the moving particles. So basically it means the behavior here refers to position, momentum, the energy possessed by the subatomic particle at a particular instant of time. So all of these come under the behavior of the subatomic particles. So there are two statements of the uncertainty principle, which is called as Heisenberg uncertainty principle, or HUP. So we'll discuss them. So the first statement of Heisenberg uncertainty principle, HUP, states that it is impossible to simultaneously at the same time describe or define the position and the momentum of a subatomic particle with absolute accuracy. It means at any given point of time we cannot exactly determine or we cannot pinpoint the exact position of a subatomic particle and the momentum, okay, mass into velocity. So this is the first statement of the Heisenberg uncertainty principle, and it can be stated in equation form as the small change in momentum, the small change in position, this is greater than or equal to the modified Planck's constant. This is called as the modified Planck's constant, which is h by 2 pi. Okay, so this is the small change in momentum is called as the uncertainty in momentum, and this del x is called as uncertainty in position. So this product is always greater than or equal to this modified Planck's constant, which is h by 2 pi. So this is the first statement which involves position and momentum. The second statement, this involves the energy of a particle and the instant of time at which the subatomic particle has this energy. So this second statement, okay, so this is the second statement. So the second statement of the Heisenberg uncertainty principle states that it is impossible to simultaneously describe the energy of a subatomic particle or a particle and the instant of time, the specific instant of time at which the particle had or has that energy, that amount of energy. So both these are very difficult to define and describe. We cannot determine these at what given point of time a particle had what amount of energy. Okay, so this is again stated in the same way as the previous one, delta E delta T greater than or equal to the modified Planck's constant. So here it is uncertainty in energy and this is uncertainty in time, and this is the modified Planck's constant. Okay, so this is the second statement of Heisenberg uncertainty principle. Okay, this relates the energy of a particle and the time at which the particle had that energy. So this first statement correlates momentum and position, the second involves energy and time. So this is the Heisenberg uncertainty principle. So here we have discussed the three basic things, the components that of quantum mechanics which we are going to use in the study of semiconductor physics, and mostly these three things will come, they will appear. So here we have discussed about some of the basic concepts related to quantum mechanics. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.